morning. I can almost see nobody here. It was a great talk. I think serverless is one of the paradigms I've been waiting for a long time. My name is Subbu Allamaraju. I am a Vice President of Technology at Expedia. And for those of you who don't know what Expedia is, we are one of the largest travel platforms on the planet. We sell hotels, cars, flights, and many more things. And just to give you an idea of our scale, we operate in over 75 countries and serving over 650 million hits, live views every month. Just to give you more context, our travel platform for lodging, for example, takes about 1 billion, it's a big B, searches every day. And we update the inventory for 2.3 billion sometimes a day. It's a fairly large, complex endeavor. And the most fun part is that we are migrating to the cloud at a massive, rapid scale. Our teams, for instance, do about 2,000 deployments a day. We used to do every other week years ago. Now we do over 2,000 deployments, and that number keeps growing. And I was checking our Lambda utilization. We were doing about 6 billion invocations a month. And that's been growing every month since about 2 years, for about 2 years. But I'm not going to talk about Expedia's cloud journey or how we use serverless at Expedia. One of my colleagues called Kuldeep Chauhan did a great talk at the last Serverless conference in New York. You should go and check it out. He talks about various architecture patterns that we use with serverless at the center of the architecture. So instead, I'm going to talk about a slightly different topic. This came about from talking to different individuals in the company and outside the company of what kind of challenges they see when they want to try serverless paradigms. Before I get into that, I want to ask you, how many of you have actually written a serverless application? Those who have done yesterday, you don't count because there was a workshop. How many of you are running in production? Awesome, that's actually more than what I expected. And how many of you had an experience where you're all excited about serverless, you did a cool demo, you go to your colleagues, an architect or a manager or someone, and try to sell him, hey, we got to use serverless for all our stuff, and you get excited, and he says, Anna, these are 5 reasons why you shouldn't do that, we are not ready for that. How many of you had such an experience? I see one hand going by. I can't see other hands. Probably there's one more on the back. So I'm going to talk about that, but I'm not going to go point by point and give you rebuttals to each of the counterpoints we hear about serverless. Instead, I want to give you some of the mental models that I developed over years. Before joining Expedia, I was at eBay and PayPal. I built the private cloud for 5 years in that company. And I dealt with data center automation, compute automation. We were a big consumer of OpenStack and a lot of open source technologies for cloud. And since then, I changed to public cloud model where we're migrating at Expedia from data center to the cloud. So it gave me a perspective of what is happening in the industry and why it is important to understand, take a step back and understand what's going on. So, let me see if the clicker works. Yeah. Let me give you a brief context of where we are in the industry. This does not cover everything that happened on the cloud space, but I took a look at certain key things that happened since 2000. 2001 is when VMware first talked about hypervisors. Since then, we had KVM came in, I think KVM later in 2008. Zen was in 2003. And about 2006, I think you remember, EC2 came along. This is the first concept to offer infrastructure as an API, through an API. And since then, there were some other developments like CloudFormation. There was Mesos in 2009. And Docker came along in 2013. Not very old, really, if you look at the entire context. It's been just 4 years. Kubernetes in 2014. Lambda came in 2014, reInvent. Azure and Google followed later in 2016. So the industry is fairly nascent, I would say, though It's good to see 200 people here in this conference. What's interesting is that in this technology industry, we spend a lot of time debating what is going on the top right corner, where we compare and contrast containers and Kubernetes and Mesos and Lambdas and whatnot. But in reality, a lot of compute is still on the lower left corner. My hypothesis is that a lot of workloads are still running on bare metal, maybe some portion running on virtual machines. Containers and functions are still a fraction of that total compute. And if you go and do a Google search on containers versus, or Kubernetes versus, you will find Kubernetes versus Docker, Kubernetes versus Nomad and whatnot. But if you go and compare, type in Google, serverless versus, you will first find containers. Why is that? Why do we compare containers and Lambdas? Because they're totally different paradigms. And then you dig into these kind of articles that talk about the pros and cons of serverless. You will hear it's not efficient for long-running applications. It's expensive. As the previous speaker shared, the call patterns are fairly complex. There are unknown security risks. There's lock-in. Even someone said it's just a fad. It'll go away because you don't need serverless to be writing applications. Observability is hard. We heard the previous speaker talk about it, which illustrates why a paradigm needs to follow a shift in how we think about problems. But I won't be able to give you point-by-point answers because that's not going to be very effective. Instead, let's understand what is actually happening. What are we trying to do in the cloud, the very basics, at the very basics. So this is how I see it. Since 2007, 2008, if you have gone to any technology conference, ACI were talking about why they are so excited about cloud. The answers, the why hasn't changed in the last 7-8 years. The why has always been velocity. Everybody wants velocity for the team. They want teams to be able to ship code, deploy code whenever they want it. And you want just-in-time allocation of resources. You don't want to approach a capacity board in your company saying that I'm going to launch a new service later this year, let's say in September this year, I want 50 servers, here's my application, and the board says approved or denied. You don't want to do that anymore. You want to get the capacity when you want it, and not more, not less. The third thing is infinite scalability. I put infinite in italics because it's sort of near infinite capacity. And this is important because every business out there has a traffic pattern. Traffic either follows certain daily trends, weekly trends, or seasonal trends. And you don't want to spend money just buying capacity for the peak. Instead, you want your consumption of infrastructure follow your traffic patterns. And finally, you want robustness. You want robustness to be given so that you don't worry about machines failing, disk breaking. You want something to take care of yourself. These things haven't changed in the last 7-8 years. But what has been changing is how we have been approaching what we are doing to get these 4 qualities. So if you go back, take a step back 5-6 years ago, this may even be true in enterprises today. If you want to deploy an application, if it's a stateless application, you provision some hardware. Probably there is some automation in your company to do the server provisioning, or maybe there's no automation. You file tickets, and then a month later you get servers. And then you figure out some automation and deploy the code. And these 2 processes are independent. If there is a machine if the machine fails, you have someone waking up at the middle of the night and try to replace the server. That's the model that we have been operating. Over last several years, that has begun to change, where we sort of figured out how to build closed-loop systems. Because the system on the left is an open-loop system. There's no feedback. In the middle, there is feedback. So when things break, we have a way to notice that and repair. So this is how the concept of self-healing systems started to take place. And we have become good at solving this for stateless applications. And the next thing that happened in the industry is we sort of figured out how to take this logic of self-healing systems and create a framework out of it. Mesos is a great example. You define a set of, create a set of policies, you pick a framework like Marathon, you deploy code using that framework onto the system, and the scheduler takes care of it. So that's how we started addressing robustness for applications over these years. Unfortunately, the stateful paradigm hasn't changed much. Stateful paradigm is you have databases, your cluster-aware applications where nodes need to talk to each other, like master-slave systems, or most distributed systems fall into that category. That hasn't changed because I think even today, in a lot of enterprises, the databases are sacred. You have a team that manages database servers, nobody touches them. They have a different culture, different operational rigor that they use. It's not as automated as stateless systems are. And over these years, despite some changes that happened in the Mesos land, the stateful remained as an independent entity in most enterprises. And that began to change in the last 3-4 years when Kubernetes came along with this idea called, there's a framework that gives you the concepts for writing distributed applications. You have the notion of pods and whatnot to help you write any stateful or stateless application and deploy it declaratively on a cluster scheduler so that you get robustness for free. This is a great evolutionary change that happened in the industry. Now, of course, along with Kubernetes, there is complexity that comes with it. There is a lot more bells and whistles that you have to deal with. But what if there's a different way to solve the same problem? I think that's where serverless comes in. The mental model I use is that you have a set of complexity for automation, whether it's stateless and stateful applications. The model that we have used in the previous slide was that there is a framework that can deal with all sorts of applications, and if I just write to that framework, I don't need to worry about scalability, I don't need to worry about consistency on the distributed systems concepts, I don't need to worry about robustness anymore. But what if you flip the model and make apps stateless again? And in fact, if you look at the application development paradigm, we talked about stateless for a number of years, but we haven't been really practicing statelessness as much as we should. And what if you have a framework that makes applications stateless, entirely stateless, ephemeral? That means you don't worry about a machine anymore. There is no identity. They're all cattle, as in the cattle versus pet analogy, or they're fungible. And what if you move all your complexity of stateful applications to managed services? In fact, this is how I understand cloud today. Cloud is no longer about IaaS, PaaS, and whatnot. It is about a set of managed services that deal with stateful applications pretty good. They're getting better and better on every public cloud. And shift all the stateless applications to a simpler framework that gives you what you wanted, which is infinite scalability, robustness, and whatnot. So this is how I explain lambdas. This is how I explain functions as a paradigm. That is, you have a serverless framework that abstracts everything that you need, like infinite scalability, just-in-time provisioning, robustness, and the velocity that you need for the teams so that your problem is much simpler. And you have managed cloud services that deal with all the complexity of stateful applications. So what about all these questions that we hear about serverless being not ready for application development? So the way I would explain is as follows. There is this thing called inversion of control that we have been good at practicing in this software engineering. Every time we figure out how to solve a problem, we try to abstract it, we try to create a framework, and the framework takes care of everything that we need to do. That is what has been happening in the serverless, in the cloud paradigm. Way back when we were looking at data centers and we started with data center resources, we build automation, we build applications on top of that automation in the data centers, But over years, we moved away from that paradigm slowly. We sort of created config management systems. We virtualized compute network. We got containers and schedulers. Now we come to a point where all the complexity of what we want, the 4 whys, robustness, velocity, scalability, and we sort of abstract into a framework, and on top of which we run the functions. This is the paradigm shift that has happened. And sort of we are still grappling with this paradigm shift because we were used to a different style of building applications, and now that's being questioned. And the second paradigm that has been happening is that the state is moving out of applications. It is moving into the services on each of the public cloud. I don't need to deal with state in my application. My application can die anytime. I don't care. So for all the goodness that happens with serverless, serverless is meaningless unless you embrace the state. You embrace the services for managing the state, without which you're not getting all the benefits of serverless. So I think what is popular, if I look at even our Expedia's journey on serverless, we are using so much serverless not because serverless is cool or it's convenient. It is because we have already so much state in S3 using Kinesis and whatnot. So it's really compelling for us to write logic as stateless functions and use that to scale it out quickly, because we are depending on these systems for managing the state. So if I use that lens of stateless becoming, like applications becoming stateless again and complexity moving into managed services, some of these questions we can get simplified. For example, when I have a system that is ephemeral, my application code is ephemeral, and it is provisioned on demand, it scales on demand. I don't need to even know how many instances of something we're running, because there's no notion of an instance in the serverless model. The inefficiency question goes away, because when I'm scaling with my traffic patterns, I don't really care, because it's just sized for my workloads. Similarly, the expensive part probably will change over time, because you may be right that today, when you compare to bare metal provisioning or even virtual machines or like EC2, the cost of serverless may be high today. But I think economies of scale will change the pricing models over years. I'm not too worried about it. Lock-in, this is probably one of the biggest reasons that I hear often that serverless is evil, because it locks you into a provider like AWS or Google or Azure, and so we need an open source abstraction to avoid the lock-in. But I challenge that premise, because today I'm not in the business of managing infrastructure and doing the heavy lifting. I'm in the business of selling travel to our customers. So should I spend worrying about lock-in to a provider as a service, or should I invest that same amount of time in solving the business problem? So I'm not really worried about lock-in, though it comes out as often, because I think agility is more important. Being able to quickly move is important. I've worked with enterprises that have so much open source in data centers, and they are locked into the data centers. They cannot get out of data centers because they are so vested in how it is set up in the data centers. Now, that experience taught me that lock-in is not the worrisome. It is not being able to change with time is the worrisome part. I can use S3 as long as it works for me. If I have the ability to move on to something else tomorrow, I'm good. I don't need to worry about it. I think practicing that ability to move is more important than worrying about lock-in. Slow and cold start, which is true for every auto-scaled system. You have to be prepared for that. I'm not going to go into other challenges here, because I think as we learn more about how to use this paradigm, things are likely to change. What is more important, though, is that understand what is going on and rationalize our approach to that. In the past, we started with in the last 7, 8 years, we start with this basic idea of we get resources like EC2, like virtual machines and load balancers and DNS and whatnot, and create frameworks on platforms on top of it, like platform as a service. That's how this idea is born, and on top of which we were creating value for our customers, writing applications. But this pyramid has been changing over the last few years, and serverless has only accelerated that change. What is happening is that at the bottom, instead of using the basic IIS primitives and try to build applications, we are actually building on higher level abstractions. And consequently, the amount of work I have to do to stitch things together has come down. And even more interesting, the problems that were difficult to solve years ago, like machine learning and AI, they have become way easier to solve. So which means that if I'm running an enterprise, I have more opportunities to look at what else I can do with the services that exist, instead of worrying about doing undifferentiated heavy lifting on IIS primitives. This is how I think of cloud. This is how I look at the value that we can create for our customers, and not worry too much about things like lock-in into cloud providers. And this is actually a comment one of someone I know made on Twitter during the reInvent conference. It says, imagine a next new-gen developer that started his career learning and working on nothing but Lambda. And he would probably figure out how to use Lambda and build applications in 5 minutes and run with it. He doesn't have that baggage that we all have of building on virtual machines and bare metal and using containers and cluster managers. So he would run with it. He's probably creating something new while we are sort of stuck in the past trying to rationalize how to fit serverless into our models. So I think what is interesting about this code is that experience shapes forever his worldwide worldview, and everything we know and do today will be not relevant for him, for that young college grad that comes out of school. I think this is what is happening in the industry, and I want us to pay attention to it and not get caught up in the serverless versus containers debate. Hope that is useful, and we have a few minutes, I think. I'll be happy to take questions.
Thanks, Subbu. Is there any questions people would like to ask? Yeah.
Yes, there's a question on that.
I'm just getting with the mic.
Hello, Gregory Magnan from Airbus. I'm very interested of transformation, IT transformation. You are selling services through internet. I'm representing an EV industrial company. Do you using this kind of new technologies for your own inner IT needs for HR, financial, logistics, supply chains, and so on, or are you using only this for selling new service to customers? I think
we started using at Expedia Serverless for some of the analytics workloads to start with, but as we automate more and more of our business like marketing, we start to see serverless adoption continue there. There is a talk that I was mentioning before at the previous Serverless conference in New York, talks a bit more of the usage at Expedia. Hope that answers the question.
Yeah, we still have 5 minutes if someone else wants to ask a question. It's okay. So anyway, you can ask questions to Subbu later if you want.
Thank you all.
Thank you.